So a little bit of a juxtaposition. We had an undergrad competing in the graduate division. Our next competitor, Mitchell Fogelson, is a PhD student working in a faculty lab commercializing research from the university. He is one of our Innovation Commercialization Fellows, which is a program to help bring technology out of the laboratories and into the commercial markets. So we also have some other investors that are with us here today. Matt Kermeyer, who's a Silicon Valley startup lawyer. Don't boo. Yeah, Matt is my boy.
That's awesome.
Yeah. We have Lisa Frankovich, who is a tech exec at a lot of Pittsburgh companies you may have heard of, and also worked as a venture partner at Adams Capital Management. We have Ed Engler, who is a longtime VC here in the region, currently with 3 Points Rising. We have John Levinson, who started as an iBanker, somewhat worse than a lawyer, but but he redeemed himself. He became a hedge fund manager and started to invest in tech companies, so we're very glad to have John. John donated the Moonshot boardroom. Ed donated the Engler boardroom back there. Zach, what are you going to donate? Zach has been with us since 2012 when we turned this into an internal competition. He is a partner at Magarac Venture Partners, MVP. And finally, we have Christine Ferguson-Rao. Christine is an M&A advisor currently. She also is with NextAct, which is a angel group that is focusing on women businesses, and we're very glad to have them. So without further ado, I'm going to hand it to Mitchell to talk about Beyond Reach Labs.
Thank you so much, Dave. Hello, everyone. My name is Mitch Fogelson, and I'm the CEO and founder of Beyond Reach Labs, where we are building deployable infrastructure for Earth and beyond. We have become so accustomed to continuous connectivity in the past 20 years, but last year's Hurricane Helene showed us how fragile our infrastructure truly is, leaving communities without internet or communication for upwards of 5 days. No data, no photos, and no messages to tell our loved ones we're safe. The current solutions to these problems are cell on wheels, or cows. And like cows, they're large, they're slow, and they are not the animal you want for an emergency response. And in many cases where roads are damaged, these solutions cannot even get access to the problem. And this costs cellular networks $5,600 a minute. And NOAA shows that the number of these events is rising every year, with 28 happening in 2023. That's where Beyond Reach Labs' deployable infrastructure supporting power, communication, sensing, and robotics, accelerating response, reducing resources, and enabling new contexts. We are 10 times the stowing efficiency to the cell on wheels and 10 times the payload capacity to the cell on wings. And our technology is backed by a family of intellectual property, from the design of our flat packing truss, configuration of our deployable mechanisms, AI optimization, simulation, deployment, and locking. And now let me do a brief demonstration and pass our prototypes around. We are better than the IKEA of infrastructure because no assembly is required. And we're not just offering a tower. We are offering a full solution to our customer, supporting payloads from SpaceX, LiDAR, Wi-Fi, radar, and so forth. And we've already signed letters of engagement with strategic payload partners. Our business model is twofold. The tower as a service, short-term leases, long-term leasing, and direct sales with the configured payloads, as well as data as a service. My years of robotics engineer serves to provide tower monitoring, sensor fusion, and data analysis. Beyond disaster relief, there are several industries that are needing this deployable infrastructure, from the defense community to our everyday experiences with bandwidth issues at sporting events and concerts, to the emerging fields of robotics in supporting the continuous connectivity for teleoperation and remote operation. Our beachhead market is to support the defense and telco companies in these defense and disaster relief scenarios. growing to the 2,300 stadiums in the United States that support over 10,000 people. And then our largest dream is to become the 2x4 for space, supporting the $100 billion lunar infrastructure market expected by 2040. And it is imperative that we develop and mature our technology with our customers in defense and commercial applications so that we're ready to support the emerging markets of robotics and space in the future. And we're doing that by building our technology in parallel by leveraging non-dilutive funding, where our technology has primarily been supported to date through NASA for the zero-G. And then we've raised a variety of capital through non-dilutive funds like the Innovation Commercialization Fellowships and Keystone Space Collaborative. And by 2028, we hope to sell 100 towers and be ready to emerge into the space market. We've built several prototypes from a 1-meter load-bearing tower to a 2.5-meter 50x extension ratio structure. And our MVP, which the funds from this program will support, are ready to support our customers immediately, from the Air Force, the City of Pittsburgh, and Kodama Systems. I've been working on robotics and robotic design for the past 12 years, and we have a strong team in space and defense. So join me in Beyond Reach Labs with our expansive innovation, bringing the beyond within reach, beyond communications, beyond defense, beyond security, and beyond space. Our technology serves multi-use industries. Our deployable structures are 10 times more effective than the current solutions, and our full solution brings value to our customers. Thank you so much.
Thank you, Mitch. Andy?
Can you describe the IP a little more? Like, what is the...
Yeah, we have a design patent on our flat packing truss structure. So this is actually a very broad patent related to the geometry that allows our system to fold and stow as efficiently as it does. We also have a patent pending on AI optimization for the inverse design of the problem. So using various sorts of optimization algorithms to design bespoke configurations of the structure. This current simulation tools, like robotic simulations, can actually support linkage mechanisms like this, and we have our own bespoke software that we've developed. And then the deployment and locking mechanism that you see here, the design of that system is also patent pending.
So is it one core geometry that then you apply to all of these different scenarios and use cases?
Exactly. So our system is scale and material agnostic. So you can make it, in front of you there was an aluminum prototype, a steel prototype. Here I've got 3D printed examples. They can be as large as 1 kilometer long for space applications or as small as millimeters in scale for internal medicine or other sorts of verticals like that. So the geometry is scalable to whatever application it could be used for. And load bearing is the most important.
For your beachhead market of defense, what is your expected prototype size, and what would you be building it in terms of cost of goods at scale?
Yeah, great question. We've been working closely with the 171st Air Force Wing out in Coriopolis, and they've given us a lot of very detailed information about the type of towers that they are looking for future mission applications, that particularly a 50-foot tower that can support 50-knot winds and a payload capacity of around 20 pounds. We estimate that we can manufacture a tower like that for around $25,000 using manufacturing partners here in Pittsburgh. So building everything locally is really important to us, especially supporting the defense community.
Lana's next.
Yeah.
I'm curious, what did you say was the largest one you've built? And in going from that size to the kinds of sizes you're talking about, what challenges typically show up? I know in manufacturing, when you go from big to small, there are a lot of challenges, but I'm not familiar with...
From big to bigger. Yeah. The tallest tower we've built there is about 8 feet tall, standing at 8 feet, and the tower we're trying to build is around 50 feet. There are a lot of challenges going from 8 feet to 50 feet, not necessarily on the manufacturing, because the design is patterned, right? So all of the truss elements are the same. We can kind of mass manufacture. We're just extending the kind of cell of the structure larger. Mechanically, there are some challenges related to the kind of forces that the top of the tower will experience, and we're working on ways such as guy wires and other sorts of staking methods to make sure that the tower remains stable and doesn't, crumble under its own weight.
Some kind of evidence that it is doable?
Yes, we've ran a variety of simulations through like FEA analysis, though, to simulate what the tower at that scale will look like, and shown that our tower should have a factor of safety that is satisfiable for the applications. Yeah.
Not to minimize this, but are these one size? Are you essentially going to be building, A, B, C type, or are these custom configurable? Do different users have to put different things on them, requiring you to make custom manufacturing to it? I couldn't tell that.
Yeah, that's a great question. We are trying to serve as the integrator, so not just supporting the towers, but also integrating the payloads with our structures to supply the full solution. Our system works best as the inverse problem. So you tell me how tall your tower needs to be, how much load it needs to carry, and what package it needs to stow in, and we can design a bespoke configuration. The manufacturing of the bespoke configuration is actually quite simple, since all the truss elements are planar and can be kind of water jet or plasma cut to size. But we think there might be some advantage of having some fixed SKUs so that we don't have too much customization within our customer environment.
So how big is a 50-foot tower that weighs 25 pounds? What are you making it out of? And is that thing 5 feet to carry around?
Yeah. Great question. The 50-foot tower will end up being, we can get up to a 15x extension ratio. So
All right, we have to hold
15
it.
divided by 50.
Just to be fair,
Thank
we have
you.
to cut it there. So thank you.
Yes,
Mitchell.
thank you so
Appreciate it.
much.